Hello and welcome to the FSCO design pitch for a brand new experimental limited edition wind turbine for residential rooftops. Now, in order to understand what we're trying to do, you must understand what a wind turbine is. So, wind turbine. It's a wind. It turns a propeller, which is attached to blades, which then connects to a main shaft, spins a generator, and inside that generator is magnets. Those magnets, they spin against other magnets, and those two magnets, when you spin around, they create free electrons. Those free electrons get you energy. That is how we're going to power your house with this brand new design. And so, we did some bit of market research. We went to Amazon, picked the top rated wind turbine they had on there. We found the WindMax H1 HY1000. Supposedly 50 pounds, it can create 1,000 watts of power, going at full speed, which is about 25 miles per hour. And if you attach solar panels to it, which are not included by the way, it's going to be 1,200 watts. Now, seeing as it doesn't include solar panels, and also it does not include a pole, mind you, this is going to run you about $1,000. So, take that what you will. So, we decided to try and design our own wind turbine. So, design constraints. We're gonna try to fit it on the roof, and so make it fit on the roof, not cave in, because if you make it really heavy, it's gonna cave in the roof, and not violate airspace. Because you see, if you make it really tall, you're gonna hit planes. That's why you can't just build a full-size wind turbine on top of your roof, because it's gonna cave in your roof and hit it with airplane. And so, yeah, as you can see from our documents, that's about what I reiterated. And so, with our materials list, we settled upon carbon fiber for the blades, steel for the outer casing, aluminum for housing the electronics, and solar panels for use as blinds when there's no wind present. The reason we chose these materials is that iron rusts, steel's very heavy, wood's a bit weaker than we would like, plastic can shatter, quartz is as well very expensive and heavy. I'm trying to make materials out of it. Ice is just, what are you doing? Dry ice, same problem. Ivory, we'll make it super fancy and also very illegal, so let's not use ivory. And so, as you can probably see on screen right now, we have a bunch of sketches. Our first initial sketch would be what the house and what the wind turbine looks with our professional animators and artists. What it looks like without any diagrams, next slide, would be how it looks like with all the diagrams. As you can see, we got a platform for mounting the wind turbine, support beams, so support beams go from the roof edges to the platform, the solar panel blinds go on top. There's the normal residential area, the outer casing that we talked about. Inside that fan, if we go to the next picture, you can see that I went for it conforms to the size of your roof. And so, by conforming to the size of your roof, it somehow fits circular blades in it. Because we went for the box fan, a giant box fan, but it catches the wind. And so, in order to fit it in there, we had a massive central fan, and then 4 outer fans that fit inside the casing to maximize efficiency. And then the square boxes, or the solar panel blinds, you can see how our concept idea is, it'll lay flat and flush with the roof, and so then it'll lift up into the wind, angle into the wind, the blades will catch the wind, it'll spin, connect to the wind shaft, and start generating energy. When there's no wind, it'll lay flat, it'll deploy its solar panels, but just like laying flat, then soak in the sun. And there you go. It works all the time. Well, except if there's no wind or no sun, but that's very odd circumstances. And so, next slide you see where the outer casing is, the solar panel blinds, the central turbine, and all the other mini fans are trying to fit it in. And so, in our engineering process, if you look at engineering design process, we started off with what we were trying to identify our constraints, which we did identify our constraints, how it has to fit on the roof. It can't cave in the roof, because that's bad, and it can't violate airspace. We researched the problem by looking at competitors and stuff. We develop possible solutions, such as we start off with like a conventional rooftop wind turbine and a bunch of other prototype ideas, and then we settle on the box fan idea that leaves flat with roof. We select the promising solution of that because it combines wind turbine with solar panels, which is maximum efficiency you can possibly get trying to do clean energy. As for prototyping, we as late cannot prototype it, but that's why we're doing the design pitch to give us the materials to design, make a prototype. Yeah. And once we get the prototype done and out, we can start testing the prototype. And then if there's any kinks or flaws we can work through, we'll redesign the design as needed.